So you're thinking, uh-oh, it's a Kirchhoff's law thing, so it's going to be really hard. It turns out that this one's pretty simple. I'll just show you, okay? Because the ideal ammeter reads zero current, right? So basically, if one of these currents is zero, this just becomes a solvable without matrices, okay? But what you're going to do is just set it up, and then when one of those currents is zero, you'll see that it's pretty simple. But let's pretend that it's not zero. So one of these currents, I'm going to call this one I1. I'm going to call this current here I2. Notice I'm guessing it's to the right. And then I'm going to call this one I3. Okay. And I think what we can say is that I1 plus I3 equals I2. Right? Now, if I3 is 0, right, then we get I1 plus 0 equals I2. And therefore, you realize that there's just one current, right? Like this, all this does is prevent anything from flowing in this direction, right? And so there's really just one current. Okay. It's almost like this part of the circuit's not even there. But let's hold on to that idea, right? Okay, there's just one current, and that current is going. That current's just going this way. Wow. And then this just becomes a simple series circuit, but let's pretend that we didn't see that. Okay, so there's that, right? And then the next thing we can do is we can do a loop equation in the upper circuit there. So let's do a loop. Let's go around just this upper circuit like that, right? So I'm going to loop in the upper circuit. I've got, let's see, I'm going to go. Did I say I was going to go that way? Okay, so I'm going to go plus 12 because I'm going through this from negative to positive, right? Then I'm going to go minus 2 I1. Then I'm going to go minus 4 I2. And then I'm back, and that's 0. Well, there's just one current, right? Remember that I1 equals I2. So these guys are just I. Okay. So really I've got 12 minus 6I is equal to 0. With some higher level math, I realize that the current is just 2 amps, right? Okay, but that's not the question. Oh, we want to find the EMF of the lower cell. Okay, so how do we do that? Oh, I know how to do this. Okay, I've got it. I'm all over this. Okay, so now we need to do another loop, right? So I'm going to do this loop in, let's do it in green. Okay, I'm going to do it from here. Okay, and I'm going to go this way. Okay, I'm going to loop around like that. Okay, so gotta go back to blue pen here. Okay, so let's do that loop at the bottom there. So the loop at the bottom there, I'm going this way. So I'm going to go plus 4I2, right? And that's because I'm going through this thing, but I'm going upstream through it, right? All right, and then I'm going to go plus 3I3, okay, minus E is 0, right? So let's do that again. So I'm here, I go upstream through I2, right? I go upstream through I3, so that's why they're plus, right? Then I go the wrong way through the battery, and I go minus E is 0, right? Now remember, I3 is 0, so we have 4 I2 plus 3 times 0 minus E is 0. It's 2, so magically it's 2. All right. So this goes away, right? Okay, I2 is the same as I1, right? These both equal 2 amps, right? So plug in 2 amps there. And I think you'll figure out that, but that's 8 volts, okay? There you go.